Please subscribe to my channel and comment in the comment box if any suggestions.
Hello friends. First chapter, basics, sets, class 11 CBSE. This starts with sets. So this is the first chapter which will be just dealing with what are all the basics we'll see. So what is a set? Set is nothing but a well-defined collection of objects. Our number systems is so huge. So first set of number systems are natural numbers. So in natural numbers, what are the numbers? It starts with 1, 2, 3 and so on. These are all well defined, and this is a collection of all these elements. These are all called as 1, 2, 3, 4 and so on up to infinity. These are called as elements or objects or members, you can tell. So these are nothing but these are all well defined. They are unique in their place. So each one has their own identity. All the students of a class is a well defined set. All these sections in your school are well defined. All the schools in your state are well defined. All the states in the country are well defined. So these are all sets. So therefore these are all collections of different objects. All those which are well defined, those are nothing but collection of your objects or sets. So now you can take, suppose we take what are all the vowels. V is for vowels, vowels of English alphabet. So what are all the vowels in English alphabet? A, E, I, O, U. How this set is denoted is, set is denoted with capital letters. So what are all the capital letters? You know that from A to Z you can take any capital letters. So all those capital letters A, B, C and so on up till Z, you can take any alphabet. These are all denoted as sets. Now how are the elements denoted? This is sets denoted in this way. Elements are denoted as, they are denoted in small letters. Small letters A, B, C, D. So this is the difference. These are the sets which create these elements. So in these sets A, these alphabets are there, that small letters you can take. These are called as the elements. These are called as the sets. So this is the difference, and basically you can tell that A belongs to capital A. This is the one symbol which is introduced. This is called as belongs to. And if you write it as A and you put a cross over this, it does not belongs to. So, okay, we'll take it as set B. So this means does not belong. This belongs to and does not belongs to this. And then we'll be having two different representation of sets. How can they be done? We'll see. Roster form, and the other one is set builder form. So what are these two forms, we'll just see, and what are the differences between these two forms also we'll see. Why are they called in this way? So here in roster form, what do we write is V is equal to, and you always have to put it in braces. This is called a braces. This is open brace and then we have to close it. So you have to write all the vowels in this, A, E, I, O, U. Now this, no matter in whichever order you write this vowels inside this braces, but it should be represented in this braces itself. And the capital letter, it should be named in a, denoted by a capital letter, and all the elements in the set should be denoted in small letters. So A is one more set wherein I am writing it as 3, 6, 9, 12, 15. So this is nothing but all multiples of 3 which is less than 18. So here you can define something, that is the element of this set A is nothing but it is a multiple of 3 and it is less than some number, isn't it? It is less than the last multiple, whatever of 3 is there we can take. It is less than 18 because 3 5s are 15, 3 6 are 18, so still 18 you can take that. So how do we represent that in the set builder form? We can write over here. I'll show you that also in set builder form how do we write. So now you can take even natural numbers. One more example we'll take for roster form. Suppose if there are numbers, I'm writing it as 1, 2, 3, 4, 5, so on. Now if there are limited numbers in this, then you can tell it is a finite set. If they are going on up till infinity, you can tell that it is an infinite set. So in representations of sets also you have finite, infinite sets. Those come under types of sets, we'll see. So now what is the set builder form? Roster form. Set builder form, we write it in this such a way that there's a property which should be written. Now suppose the same thing, now I'm writing v itself. V is nothing but the set of vowels. How do we write this? This x is nothing but that element possesses a particular single common property. So what is that single property which it possesses? We'll just write x is a vowel in English alphabet. Here this x is nothing but it is that object which is having a common property. That is, now a is having this property. Is it a vowel in English alphabet? Yes. E is a vowel in English alphabet. I is a vowel in English alphabet. O is a vowel in English alphabet. U is an vowel in English alphabet. So each and every element of the set A should consist of that property. Now how do we write A? A is equal to set of all x such that x is a multiple of 3 less than 18. The last multiple which it is less than, we have to take that. So x such that x is a multiple of 3 less than 18. So this is the way. And what are this? Now you can see 3 is a multiple of 3 less than 18. 6 is a multiple of 3 less than 18. 9 is a multiple of 3 less than 18. 12 is a multiple of 3 less than 18. 15 is a multiple of 3 less than 18. Word principal. Now how do we write this as a set? When you're writing what are all the alphabets of this word principal, how do we write this? So if you're taking the set, you're naming the set as A. So what are all the alphabets? We can write it as P, R, I, N, C. Now here you're getting again I. I is repeated. It is already there. So you cannot repeat it again. So you just write a comma, then put an A. Then because P is also repeated, you cannot write P. So IP is already there. So you can just write this AL. Write it. This is a set of collection of well-defined objects wherein you are not repeating any alphabet. So now what are the different types of sets we'll go into? So what is subset and superset? Subset and superset of a set. Example, consider an example I'll do. A is equal to 1 and 2 and B is equal to 1, 2, 3. Now here A is said to be the subset of B. That means because it is consisting of two elements of this B, that's why it's said to be subset. It is either equal to or less than. If it is equal to, then you can tell both the sets are equal. But because it is less than, having one element less than it, and they are also equal to it, isn't it? So therefore, if I take A is equal to 4 and 5, I cannot tell that this C, suppose I'm taking one more set C is equal to 4, 5. I cannot tell that this 4, 5 is a subset of B. I can tell only A is a subset of B because it is there, these elements are there, and it is less than this these three elements also. So that's why A is a subset of B, and it is also, you can tell that now here this you can tell that 1 belongs to set A. This is denoted as this is belongs to, and then you can also tell 3 does not belong to A. So this does not belong to A. Now here you can write C is not a subset of B. You will write C is not a subset of B in this way. This is subset. This is denoted as subset. And if it is not a subset, you write it is not. Put a line through it and tell that C is not a subset of B. Now, in this same example, you can tell that B is said to be the superset of A because it is having one more element than A. That's why it is said to be the superset of A. Got it? So now this is B because it consists of more elements than A. That's why it is said to be a superset. Now next, what are the different types of sets we'll go into? So what are the types of sets we having? Types of sets is, first one is singleton set. Singleton set is a set which consists of only one element. That is, suppose if I am defining it as A is equal to 2 or B is equal to some alphabet A. So therefore this consists of only one element, therefore it is said to be a singleton set. Now next, what is empty set? Empty set is also called as null set. So now here in empty set means there is no element in this. Without any element a set is there, then it is called as empty set. So if you will denote it in this way, or A is equal to, or A is equal to void or null set. Okay, so therefore you have that this empty set A, empty set is a subset of every set, is a subset of every set. Power set we'll see. Power set is a collection of all the subsets of a set. If A is equal to, I am taking an example, if A is equal to 1 comma 2, so all which contains all the subsets of this set is said to be a power set. So what are all the subsets? We have seen that empty set is also a subset of every set. So first we can denote in that. So power set is denoted as P of A. Okay, so this is nothing but equal to, first we can write the empty set or null set, then it can contain of the singleton one, it consists of this one element, this is also a subset of A, 2 is also subset of A, then 1 2 is also subset. It is either equal to or subset. So then it's said to be all the subsets of this set A are is said to be a power set. So this is P of A, and this P of A consists of how many elements is, it is represented in this way. N of power set of A consists of how many elements is 2 to the power of n. That is because here 2 elements are there, it is equal to 2 square, which is equal to 4. So you can see 1 2 3 4, these are the 4 elements which are there here. So now next, what is a finite set? Which consists, finite set is nothing but a finite set which consists of finite number of elements. Infinite set is a set which consists of infinite number of elements. I am not going to that. Then we'll go into what is universal set. Universal set. What is this universal set? We'll see. So any set which is a superset of all the sets under consideration. Example here, suppose I say P is equal to, suppose I take 3 5 and 7, and one more set I take it as 2 4 6. Universal set is either denoted as S or U. I am writing it as U. U is equal to 2 3 4 5 6 7. This is called the universal set. Which, so equal sets we have next. Equal sets, suppose you are having P is a subset of Q and Q is also the subset of P, then we can tell that P is equal to Q. So that means, suppose P is equal to 3 6 8 and Q is equal to 6 3 8. I told the order doesn't matter, but here if they are both subsets, exactly the same elements you're having in both of them, so therefore same elements, therefore P is equal to Q. Next we'll go into what are called as open and closed intervals. First we'll take what is open interval. Now if I take both of them are in this way, and here if I take in this way. Okay, so now here -2 -1 means we are putting this type of bracket. This is called as open interval. That means in open interval what happens is all the numbers between -2 and -1 are existing, but it is not including -2 and -1. In this, between these two, it is not included -2 and -1 here. So this is said to be, you write it in this brackets, that's why we put an open interval. Now this is said to be closed interval. That means here you are including all the elements between 1 and 2 and also 1 and 2. So this is said to be an closed interval. This is called as closed interval. Now suppose if I write x is lying between 3 and 5. Now here what happens is, I can write this in this way. This x lies between 3 and 5. It is not including 3 and 5. I am writing here when if it is written in this form, that is 3 is less than or equal to x is less than or equal to 5. Here we write that 3 and 5, all the elements between 3 and 5 and also 3 and 5. This is closed interval, and this is said to be open interval. So remember, this type of bracket whenever we are taking, this is said to be open interval and this is closed interval. So this type whenever we are using, so suppose you are having a is equal to x such that x, in set builder form I am writing x is an integer such that x lies between -3 and 7. So now how do we write this in interval form? We can write this as -3, 7. Here we put this type of bracket. Got it? So then we tell that this is a open interval. Now how do we write some of them in set builder form and roster form? We have seen. Here also you can write. Now suppose you are having on my example, if x lies between -2 and 5. So now here what is happening, I am taking here less than or equal to and here less than. So here you can see that this interval is -2, it is closed here and it is open here. And if you take one more example, suppose your x is 2 and 10. So you can take this as 2 open and it is closed near 10. So if you take it on the number line also, you can take it in the same way. Suppose here 0, this is 1, this is -1, 2, -2. Now suppose you are having this part, I am taking it in this way and this. So how do we write this interval? You can write it as -1 is closed. That means it is including this -1. It is including. Wherever this dot is there, it is including. And wherever 1 is there, it is not included. This open bracket is there, it is not included. Open, this is open, not included. 1 is not included here. 1 is not included. This is closed. -1 is included. Got it? So this is about your open and closed interval. Now you can tell for natural numbers, n is equal to set of all x such that x is a natural number. So now how can you write this? You can write this as -infinity less than x less than infinity. We are writing here open interval. Always whenever infinity is taken, it is taken as open interval. You don't take it as closed interval because you don't know what is that infinite number. Now next, what are Venn diagrams? We'll see. Venn diagrams. So Venn diagrams, this is actually, this Venn is a name by a mathematician, John Venn. He has he's the person who has invented these. So now you're having, suppose you are going to include in this Venn diagrams rectangles for the universal set and all circles for all the subsets. For all subsets we'll use. So now suppose if I take for example, this is the universe. In this universe there is a subset A. Okay. So now here I can tell that in this this is 1, 2, 3. You have 4, 5, 6, 7, 8, 9. So this is universe which we can write. So here our universal set consists of all the elements which are there in that universe. In that rectangle part, whatever is there in the circle also, universal set means 1, 2, 3, 4, 5, 6, 7, 8, 9. This is universal set. What is the subset of this universal set? This is A, all which are represented in that circles. So this is only the elements in the subset. So now what are the different, now suppose you can also represent it for taking different operations on this also for you all. So we'll use the different what are the different mathematical operations on sets. We'll see mathematical operations on sets. So what are the different mathematical operations on sets? We'll see. First one is union of sets. So union of sets means it's combining both of them, and it is denoted as this U. Okay, so now suppose if I take, for example, what is this union of sets? We'll see. If I take A is equal to 1, 2, 3, 4, 5, 6, and B is equal to one more set in which you are having 3, 5, 7 and 8. So now here, taking our universe, that is Venn diagram, will take this. How it is represented, we'll just see. If you're taking line here, so if you're taking two circles inside this is A and this is B, this is our universe. What are all which are common in both of them? That is, universe is nothing but here this is the element 1, 2. Now 3 is common in both of them, so we write in this part. I'll tell you what is it about. And even 5 is also common, so we're writing 3 and 5 in this. 1, 2, 4, 6 is over here. 4, 6, and here you're having left out with 7 and 8. So what is A union B is nothing but it is equal to 1, 2, 3, 4, 5, 6, 7, 8. It is there, 3 and 5 are there in both of them, but we don't repeat it twice because it is in this universe. Whatever you are having in this universe will become A union B. Okay, so that means whatever are there in the rectangle part, all the elements which are repeated only once. So therefore your whichever, now 3 and 5 are there in both, so I have written this middle circle. That means it is common for both of them. Okay, so A union B is nothing but equal to this. Now you can take some properties of these sets, properties of union. What are the different properties of union? We'll just see. So first one is A union B is equal to B union A. This is our commutative law. Commutative law. Then you are having second A union B one is A union B union C is equal to A union B union C. This is associative law. Then you have next what is called as identity law, where A union phi is equal to A. This is phi is the identity element. Phi is the identity element. So this is said to be identity law. Then the fourth one you're having A union A itself, that is equal to A. This is called as idempotent law. Idempotent law. That means the union of itself is nothing but A itself. Then next you're having fifth one. What is universal union of A? Because universal is one of the biggest head of the, this is union. Universal union A is equal to nothing but U. This is law of universe or law of U. Okay. Now going into what are intersection of sets, we'll see. Intersection of sets. In intersection of sets, what do we have? Now the same example we'll again denote it in this way, and here this is denoted by reverse U. Denoted by reverse U. There you had the reverse, the other part. Now here it is in this part. We'll take a Venn diagram here also. The same example will take. A is equal to, here again you're having what is A, what is B. So A is equal to 1, 2, 3, 4, 5, 6, and here B is equal to 3, 5, 7 and 8. So now here you can have, here again here you're having 3 and 5 are common in this, and 1, 2, 4, 6 are outside, and here 7 and 8 are there. This is A and this is B, and this is universe. So now what is A intersection B from this is, A intersection B is nothing but the common part, common elements of both of them, that is 3 and 5 are the common elements in this. So therefore your intersection set consists of only these two elements, 3 and 5. What is common in both of them? That will be the intersection of sets. Now you are having properties of these sets also. What are the properties of intersection of sets is, here you are having A intersection B is equal to B intersection A. This is nothing but commutative law. Commutative law. Next you are having second, what is your associative? A intersection B intersection C is equal to A intersection B intersection B C. This is associative law. Next you are having what is called as identity law here, the third one, or the identity element pi. Intersection of A is nothing but whichever is the smaller set in this, you will get that, or union, and you are having this also, universal set intersection, whichever is the smaller set. Universal will always be smaller, isn't it? So this is the identity law. Then you are having fourth one, the idempotent law is A intersection A is equal to A itself. This is idempotent law. Idempotent, this is identity law. Idempotent law. And then you're having what is distributive law in this, A intersection B union C is equal to A intersection B union A intersection C. So this is a distributive law. Now next, last one, we are having what is called difference of sets. Difference of sets, here you are having if you are taking two sets A and B, the difference from A to B is all A minus B is nothing but all the elements from B you will remove, and only the elements of A will be left over there. Suppose for example I am having A is equal to 1, 2, 3, 4, 5 and 6, and B is equal to 3, 5, 6, 8. So here you are having what is A minus B is equal to, so you remove all those elements which are common in both of them. So 3, 3, 5 you are having, you are removing this, then 6, remove 6 here. So what is left? Only in A we have to see what is left. So A, 1, 2, 4. Only these three elements it's left over with. Now what is B minus A? We'll see from this. B minus A is equal to, now here you are having, this is B is equal to 3, 5, 6 and 8, and A is equal to 1, 2, 3, 4, 5 and 6. So now here B minus A means you are having which common in these two? So 3, 3, 5, 5, 6, 6. So what is left over in B we have to see. So 8 is left over. So B minus A is nothing but 8. Got it? Now suppose if there is nothing common, if this is, you take A minus B, A intersection B and B minus A, all these are nothing but are mutually disjoint. Mutually disjoint means they are all different from each other. Mutually disjoint. So you can see from the Venn diagram, I will draw the Venn. So if you are taking a Venn diagram, in this Venn diagram, this is A, and this is B. This is the universe. This is A. This is B. So you're having, this is nothing but A minus B, this part, and B minus A is this part, and what is left over here in between is A intersection B. So all three are disjoint complement of a set. So here A is there. So complement of A is represented as A dash. It is here, this is the universe. So complement of A is nothing but, if you remove A from the universe, that is the complement. That means U minus A is said to be A complement. That is, if you're having universe is equal to 1, 2, 3, 4, 5 and 6, suppose this is the universal set. If A is equal to 5 and 6, your A complement is equal to U minus of A, which is equal to, if you remove this 5 and 6 from both of them, you're going to get it as 1, 2, 3 and 4. Some properties which are there, which are very important, which are to be remembered. The first one is A union A dash is equal to U. Then second, you're having A intersection A dash is equal to 5. Then third, this is De Morgan's law. De Morgan's law is also very important. First one, in De Morgan's law, you're having two bits. A union B whole dash is equal to A intersection B dash, and second, you're having A intersection B whole dash is equal to A dash union B dash.
If you like this video, please comment and please subscribe to this channel and hit the bell icon so that notifications for the next chapter also will be coming to you all. Please subscribe to this channel and please give comment, and if you all want any other chapter also, please comment in the comment box. Thank you.